In our last section now of Chapter 4, Topic 5, Systems of Inequalities. Here are the objectives. We're going to do linear inequalities now in two variables, graph them and use a math model. Now again, linear inequalities in two variables, we would have the standard form of the linear equation, but now we're introducing once again the inequality symbols. Now remember, once we do an inequality, there are whole regions of solutions as opposed to just one value. And test points would be used to indicate the region that makes it true. The graph of an inequality in two variables is the set of all points. Again, this is a region whose coordinates satisfy the inequality. The protocol for solving is mentioned here, where we replace the inequality sign with an equal sign and find the particular line, and then go to determine through test points which is the, in a sense, shaded region, the area of solution. In example 1, we'll see this illustrated. Let's write this now. 4x minus 2y equals 8. But keeping in mind this was originally greater than or equal to, and we'll go to the whiteboard. So there's a number of ways to do this. I would suggest solve for a positive y. Well, I would put the y value on this side, move the 8 to this side, and that's an x there. And then we're going to divide everything by 2. And we get that y, and this is 2x minus 4. So this is in slope-intercept form. Y equals mx plus b. So if we wanted to make a quick sketch of this, our y-intercept is a negative 4. So 1, 2, 3, 4. Our slope is 2 over 1, positive, so we're going to go over 1, up 2, over 1, up 2, over 1, up 2. So we get a line that looks like so. Now, we're now going to replace that equal sign with a, remember we moved it to this side, so this was something that looks like this. And if we want to write this now, it's going to be y. Notice the point is this, y is less than or equal to 2x minus 4. And now what makes this statement true? Well, we might put the origin as a test point here, which is 0, 0. So if y is 0, x is 0, is 0 less than negative 4? Well, on a number line, 0 is not less than negative 4. 0 is greater than negative 4. So this is not the area of solution. the area of solution would be on this side. And we would use a solid line because it's also equal. So being this configuration of the inequality sign greater than or equal to, anytime it's equal to, it's a solid line. Now, if it was only, let me just change that here. If it was only less than, this would not be a solid line. This would be a dotted line. Okay, let's take a look at the other and see what the book is providing here. Clear that up. There's our line. And they're using also 0, 0, which is a good one. So this is not in the area of solution. So the proper shading would be what we had. Good. Something else I found as sort of a shortcut. When you solve for a positive y, and it says y is less than, that indicates the area of solution is going to be under the line of the graph. So that's what we see here. Now, if it was y is greater than or equal to this, the shaded area would be above the solid line in this case. Now, in example 2, we're looking at this inequality. Now, we saw in a previous lesson, this shape is a circle. And it's saying that, again, if we were to solve it for y, it would be y squared is greater than or equal to a negative x squared plus 16. So using that little shortcut we just mentioned, where do you think this would be shaded? Would it be above the line here? And the answer is yes. So the area of shaded would be above. And using the 0 formula for our circle, we see this is a circle whose radius is 4, and the center is the origin. So if x is 0 and y is 0, putting those values in here, this would be 0 and 0. Is 0 greater than or equal to 16? No. So this would not be the area of solution. It would be on the outside. So we could solve it, and let's clear this up here. And they're showing that that is a false statement, and therefore the green shaded area is the area of solution. Going on now to our next example, the latest guidelines, which apply to both men and women, give healthy weight ranges rather than a specific weights for or your height. It expresses in these two equations, or inequalities, I should say. Now, the question here is, show that this is in a solution area for this system. Well, what are we going to do? Well, we're going to put the 66 for the x and a 130 for the y and see if this statement's true. And then do the same for this, if this statement is true. Now, this is sort of an easy one because they have it all worked out for us and they show the substitution, and it is true. So what does that result in? It results in saying that this point satisfies both inequalities. I think this is something easy. All right, let's go on to our last example now, which is graphing systems of linear equations. And the protocol for this is sort of straightforward. We have two systems here. In this first one, notice it's only a less than as we see it here. So the graph of this is going to be a dotted or dashed line. Those values that are on the line are not included in the solution area. And when you have an inequality greater than or equal to this, the line values are included. Okay, so what's the protocol for solving this? So they're solving it by using the intercepts, and I'll do that too. So whenever we want to find the intercepts, we said a good protocol would be to make an X and Y-intercept t-chart. So a 0 there and a 0 there. And we'll do it for this side too. This is that special t-chart that we mentioned earlier in the course to find our X and Y-intercepts. And let's do it. Now, if X is 0, our Y value here is going to be a -2. Remember, we're replacing this with an equal sign. Now, notice that these values are not going to be solutions, but they will outline where our line would be. And then if Y is 0, X is going to be 6, okay. Now over here, again, this is equal. Well, these values are included. If X is 0 here, this is going to be a -2. So we have intersecting Y-intercept points here. And then here, this is going to be a -3. So let's create the graph. We're going to just sketch it here. Something, the book is going to show us a nice one here shortly. Okay. So let's plot this one. This is going to be a -0, -2, which is right there. And this is going to be 6, 0. So 1, 3, 4, 5, 6. This is just a sketch. Now this line is going to be a dotted line. Now we haven't determined whether we're going to shade above or below here. And we're going to use our little shortcut method too, and then we'll determine something. And then for this one, let's change colors. Let's use black for this here. This is 0, -2, so right there still. We said this would be a common point of intersection. And then here this is 0 or -3, 0. So 1, 2, 3, right there. Now this is going to be a solid line. So I'll use my line tool here and make a solid line. Now we have to determine where our area of solution would be. And I'm going to go back to red. Now we could use the point 0, 0, but let's just figure out by looking at the inequalities. Now remember, to make this positive, I'd have to move the y over to this side. And this would now become a positive y. And positive y is greater. So we're saying we are going to be shading above this dotted line for this. And for this one, y is already positive. So I'm saying we're shading above this line for the black one. So what is our area of solution then? I believe it will be this. And if we were to put 0, 0 in both of these equations, we find that would make both of these true. So if this were 0 and this was 0, is 0 less than 6? Yes. And if this is 0 and this is 0, is 0 greater than -6? Yes. So this is our answer. So let's clear this up. Go back to our regular board, and they're finding the intercepts. We did it as well. And believe it or not, they get the same equations we did. Again, this one is dotted because it's only an inequality. This line is solid because it's also equal to. They're using the test point 0, 0, which makes it true. So this is our area of solution, or we shade the solution region. Okay, well, this was sort of a short lesson and hopefully easier than what we've been doing, and we'll wind it up.